Okay, so for any sets A, B, and C, we want to prove that A cross B union C is equal to A cross B union A cross C. So what we're going to do is we're going to develop this cross product representation here, and we're going to let A be this little piece here. So this is A, right? And then B and C are going to share the same line here. So we can do B, and then we can even do C here, right? So C and B, right? So let's represent this cross product like this. Okay. So this is where A and the space A with B meet, and this is the space where A and C meet. Okay. So as you can see, this is the space, and this is the space, right? Okay. So what we're trying to prove is that A cross B union C, so B union C, A cross it, that's all the points in here, right? And remember, all these points are going to be coordinates, right? So all these points in here is the same thing as A cross B union A cross C, right? With the picture, it's pretty obvious, right? So A cross B union C is the same thing as A cross B, right? That's this space here. That's A cross B union A cross C, right? So clearly the same thing, right? So that's basically what we're doing here. So let's go ahead and start the proof. So proof, we're going to have the point xy, right? Since this is a cross product among sets, right? We know that every one of these points in here is a coordinate, right? So x is an element of A cross B union C, right? So by definition of cross product, this means that x is an element of A and y is an element of B union C, right? So up with the picture here. So we can say that y is either in here, right? So maybe this could be y and x is somewhere here, right? So that means this point is what we're talking about, right? This is the point x, y, right? But x, we know that x is in A, right? For sure. And y is either in B or C, right? Okay. So now by definition of union, this means that x is an element of A and let's do y is an element of B or y is an element of C, right? So now you guys can see this is of the form P and Q or R, right? And we know that this has a logical equivalence, right? We know that this statement is going to be equivalent to x is an element of A and x or y, sorry, y is an element of B, or x is an element of A and y is an element of C, right? This is P and Q or P and R, right? So we know that P and Q or R is logically equivalent to P and Q or P and R. So that's why this statement is equivalent to this statement. Okay, so now we have x is an element of A and y is an element of B. So this means that xy is an element of A cross B, or, right, or we have xy is an element of A cross C. And then, of course, this gives us that xy is an element of A cross B union A cross C. So this gives us that for every xy being an element of, let's go up here, A cross B union C, leads us to, right, leads us to A cross B union A cross C. So this tells us, of course, that A cross B union C is in fact equal to A cross B union A cross C. And that is the proof.